I'll close out this video with comparison properties of the definite integral. If f of x is not negative on the interval from a to b, then the integral from a to b of f of x dx is also not negative. And in that event, we get the area under the graph of f from a to b. If we have two functions, f and g, and f is never smaller than g on the interval from a to b, then the integral of f from a to b is not smaller than the integral of g from a to b. And then this last one's a little much. If f of x is between two values, lowercase m and uppercase m, then the integral is between two values, m times the quantity b minus a, and then uppercase m times the quantity b minus a. For this one, I'm going to draw a picture. Here I have a function f, and we're looking from a to b. If the smallest value of f on the if the smallest value for f on the interval from a to b is lowercase m, and the largest value for f on the interval from a to b is uppercase m, then the area under the curve is going to fall between a rectangle that has a width of b minus a and a height of lowercase m, and the rectangle that has a width of b minus a and a height of uppercase m. This picture should make it pretty clear. And if that wasn't clear, this should do it for you. The black area is between the size of the green area and the size of the blue area. Now we're asked to use a comparison property of the definite integral to estimate the value of the integral from 0 to 3 of 1 over x plus 4 dx. I think a visual will be helpful before we get into what comparison property we're going to be using. And here we're just going to draw a quick sketch of y equals 1 over x plus 4, which has a vertical asymptote where x is equal to negative 4. And it's a shift of the reciprocal function. And we're looking at the interval from 0 to 3. So we're finding an estimate for that area. Notice that this function is decreasing. That's kind of good to know. It's like there aren't any wiggles in it or anything. And let's look at the left endpoint function value. F of 0, we'll call this f of x, right? F of 0 is equal to 1/4, and f of 3 is equal to 1/7. Therefore, what we can say is on the interval from 0 to 3, 1 over x plus 4 is between 1/7 and 1/4. If you weren't sure, we're going to use this comparison property that says that if a function is between two values, then the integral of that function over an interval from a to b is between two values, the sizes of two rectangles. Over here, there's a smaller rectangle that has an area of 3 over 7, 3/7. And there's a larger rectangle that has an area of 3/4. And of course, I'm getting that because we have an interval width of 3 times 1 over 7 and an interval width of 3 times 1 over 4. The area of the region I've denoted in black is in magnitude between the area of the green rectangle and the area of the blue rectangle. Therefore, the integral from 0 to 3 of 1 over x plus 4 dx is between 3/7 and 3/4, and that's all we're asked to do here.